Welcome you all to the week 3 tutorial of the course Differential Equation for Engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of vector geometry and dynamical systems. In this tutorial, we do some illustration that are based on, first of all, the theory of second order linear ODE. We will extend solving the second order linear ODE with constant coefficient to the nth order linear ODE with constant coefficient along with the existence and uniqueness theorem. Then after we will solve some special kind of differential equation, that is Euler-Cauchy type differential equation. After that, we will learn how to solve non-homogeneous equation with the help of two methods. One is method of variation of parameters and the other one is the method of undetermined coefficients. So let me start with the first question. Find the general solution of the differential equation y triple dash plus 6y double dash. Here is dash denotes the derivative. 3 times dash means third derivative of y with respect to x. So try this one, then we'll discuss it. So clearly this is a third order linear ODE with constant coefficient. So we'll follow the same approach as we have done in the second order linear ODE. What we will assume that let yx e to the power lambda x be a solution of this differential equation given in 1. Next, we will find out its derivative. Lambda square y triple dash x is, and we will put all these values in equation number 1. So what we will get? Lambda cube lambda x plus 6 lambda square 11 lambda 6. So if you will solve it, you will get plus 11 lambda plus 6 into e to the power lambda x is equal to 0. We know that we know that e to the power lambda x can never be 0 for any value of x. So let me write it properly. For any value of x. So what will be 0 then? This polynomial in lambda, third degree polynomial in lambda will be 0. Now we have to find out its roots. So clearly lambda equal to -1 will satisfy this equation. So one root will be -1, so it will be lambda plus 1. The other factor will be some quadratic factor that we can explicitly calculate with that discriminant method. So what will be that? Lambda square plus 5 lambda plus 6. It would be like this. If you will factorize it, you will get lambda plus 2 lambda plus 3 equal to 0. So lambda can be -1, -2 as well as -3. So what are the solutions you will get? One is e to the power -2x. Other one is, let me start with this, -3x -2x e to the power -x. So these three Li solutions of 1. So if you remember that existence and uniqueness theorem, if the differential equation has this kind of form with these coefficients as continuous over whole domain, and here domain is real number, so it is a continuous function since it's a polynomial, so it has maximum n Li solution, or you can say the linear combination of these Li solution will be the unique solution of this differential equation. So we found this Li solution, and what is linear combination? It will be C1 e to the power -3x, C2 e to the power -2x plus C3 e to the power -x. So this will be general solution of 1. Okay, any doubt? So if not, then let me write the next one question. Solve y double dash minus 3y dash plus 2y equal to e to the power 3x by the method of undetermined coefficient. So let me just give you a hint, then you will try also. Clearly, this given differential equation is non-homogeneous differential equation. So yx, the general solution will be sum of homogeneous solution and this particular solution. So homogeneous solution will be found in the same way that we have done this in this question number 1. And for particular solution, we have to follow this approach method of undetermined coefficient. Try this one, then I'll let you know. So let me just first find out this homogeneous solution or homogeneous part, you can say. What is its homogeneous part? It will be 2y equal to 0. So same with the above approach, we can say that we will get lambda square minus 3 lambda plus 2 equal to 0. So what will be the solution of this? Lambda minus 2 and lambda minus 1. So lambda can be 1 comma 2. So our homogeneous solution will be C1 e to the power x plus C2 e to the power 2x. So now what will be ypx? For that, we know from the lectures we have two approaches. One is method of variation of parameters and another one is method of undetermined coefficient. So here we have told explicitly to apply method of undetermined coefficient. Still, I will mention one thing, that method of undetermined coefficient has a limitation, that it must be applied on the differential equation which has constant coefficients. Like here, it has constant coefficient 3, 2. If it has suppose variable coefficient, then this method of undetermined coefficient will not be applicable. So since here this is constant coefficient, so we can apply here method of undetermined coefficient. Now the next question is what method can be used or what approach can be used. So we used analytic method. Analytic method means here in the right hand side we have the function, simple function e to the power 3x. So we have to think about for which kind of differential equation e to the power 3x will annihilate. So if you remember, uh, d over dx of e to the power ax will be a times e to the power ax. So you can say that d by dx minus a, if you apply on this function, it will become 0. So for the e to the power ax, this will be its analytic differential equation or analytic equation. So here for simplicity, we will denote d equal to d by dx. So that means d minus a e to the power ax will be 0. So this is just for the our non-homogeneous part. But here is some homogeneous part. So our equation, if we will write in the same d form, so it will become d square minus 3d plus 2 applying at y is equal to e to the power 3x. It will d square 3d plus 2 and y we have applied explicitly. So what we want to say, we want to annihilate all this differential equation. So what we will do, we will apply d minus 3 on both sides. This d square minus 3d plus 2 we can also explicitly write as d minus 2 d minus 1 applying at y d minus 3 at e to the power 3x, and we know that this is nothing but 0. So we came to this homogeneous kind of equation. Okay, so what will be this values of this lambda or equation will be, first of all, this will be lambda minus 3 lambda minus 2 lambda minus 1 will be equal to 0. So lambda can be 1 2 3. Now what will be our solution in this particular case? We call it as some auxiliary solution. So it will be C1 e to the power x plus C2 e to the power 2x plus C3 e to the power 3x. Now observe that from this homogeneous part solution, we already have a combination of e to the power x or e to the power 2x, but we don't have e to the power 3x. So we are not interested in this part. We are just interested in this particular part. So what we will say, we will consider, we will look for particular solution of the type ypx is equal to c3 e to the power 3x. We are just interested in this kind of solution since our RHS contains a e to the power 3x. So if you will observe this coefficient we have to determine. So that is why we call this method as the method of undetermined coefficient. So we have to determine this coefficient. How? Since we are saying that ypx is a solution, particular solution, then obviously it must satisfy the given differential equation. So to satisfy the given differential equation, we need to calculate its first derivative and its second derivative. So let me first calculate that one. It will give you 3c3 e to the power 3x, and yp double dash will give you 9c3 e to the power 3x. So our equation is y double dash minus 3 times of y dash plus 2 times of y equal to 0. Since we want to, oh sorry, equal to 3x. So since we want to put our yp in this solution, so it will come out to be 9 c3 e to the power 3x. Since it was minus 3, so it will be minus 9 c3 e to the power 3x plus what was next? 2y. So 2 times of c3 e to the power 3x is equal to 3x. So these two terms will cancel out and we get 2c3 equal to 1 and c3 equal to 1 by 2. That means our ypx will be e to the power 3x by 2, and our general solution will be sum of homogeneous solution or sum of this particular solution. So c1 e to the power x, c2 e to the power 2x plus e to the power 3x by 2. This will be our the general solution of the given non-homogeneous differential equation. So comparing to this question number 1, I am giving you one more question. Solve y triple dash, in fact y 4 time dash 8y double dash plus 16y equal to 0. Again, this is a fourth order linear differential equations with constant coefficient. So approach will be the similar as we have followed in question number 1. So try this one. This is somewhat easy for you. Any answers? So we will follow the same approach. Excuse me. Let yx is equal to e to the power lambda x be a solution of, I will name it as 2. Second. So be a solution of this equation number 2. Then following some calculation step, we will get to its derivative is 4 times. So it will be 4 plus 8 lambda square plus 16 equal to 0. So this will, if you will observe it, it is nothing but lambda square plus whole square equal to 0. So lambda square plus 4 equal to 0 2 times, I can say. So the root will be plus minus 2 iota and plus minus 2 iota. Okay. So since we have repeating roots, so what we will do, we will multiply one solution with x to make the linear independency of the solutions. So what we will be our first solution. It will be e to the power 2 iota x. Y2x will be e to the power minus 2 iota x. Again, it's going to be repeat. So what we will do to make the linear independency maintenance, we will multiply with x, and this will be x. So these are 4 Li solution of this differential equation given in 2. Next, what will be general solution? That will be the linear combination of all of these solutions. So d1 e to the power 2 iota x, d2 e to the power minus 2 iota x plus d3 x 2 iota x, d4. So if you will solve it a little, so you will get e to the power 2 iota x is cos 2x plus iota sin 2x. So if you will substitute its value, so I am just giving here reasoning, e to the power iota theta is cos theta plus iota times sin theta. So here it will be cos 2x plus iota sin 2x. Next one will be d2 times cos 2x minus iota sin 2x. Next one is d3 x. We can take common x. So d3 times x cos 2x plus iota sin 2x, and the other factor is d4 times x cos 2x minus iota sin 2x. So from here we can combine the terms of cos 2x and sin 2x and x cos 2x and x sin 2x. Like we will get d1 plus d2 cos 2x. Next one is iota d1 minus iota d2 sin 2x. Next one is x times d3 plus d4 cos 2x. Or precisely I should write in d3 plus d4 times of x cos 2x, and next will be iota times d3 minus iota times d4 of x sine 2x. Since d1 plus d2 and these d1, d2, d3, d4 are arbitrary constants, so we can replace it with some c1, c2, c3, c4. So it will be c1 cos 2x, c2 sine 2x plus c3 x cos 2x plus c4 x sine 2x. So this will be, sorry, so this will be general solution of the homogeneous fourth order linear differential equation given in equation number 2. Okay, so till now we have learned how to solve the constant coefficient higher order differential equation. Higher order means nth order. Here we have done two questions. One is over third order linear differential equation and another one is fourth order linear differential equation. And we have done one question with the constant coefficient and non-homogeneous equation. We have find its particular integral with the help of method of undetermined coefficient. So let me give you one more question over this method of undetermined coefficient so that you can get habitual of it. So use the method of undetermined coefficients to find the general solution of differential equation y double dash plus 2y dash plus 4y is equal to triple one times e to the power 2x cos 3x. So again, we have to find its homogeneous solution first, then its particular solution with the help of analytic method, or you can say using this method of undetermined coefficient. So try this one. After that, we will discuss. So let us solve it. So we know that if we have e to the power ax, then analytic differential will be like d minus 2y something. So, but here it's a multiplication of cos 3x also. So, corresponding to this, we need d minus 2, 0. While for cos 3x, what we need? Cos 3x, sin 3x is a solution of some kind of 3 iota plus minus 3 iota. So, corresponding to plus minus 3 iota, we need the differential operator to be like this. Cos 3x equal to 0. So if you will combine these two, since we are e to the power 3x cos 3x, so then it will be d minus 2 d square plus 9 e to the power 2x cos 3x equal to 0. So this will be only for the particular part. And for the homogeneous part, if you will write it, so it will be d square plus 2d plus 4 times y is equal to 111 e to the power 2x cos 3x. So since we want to annihilate this one, so what we will do, we will operate this two whole differential equation or whole equation. So this will be d minus 2 d square plus 9 d square plus 2d plus 4 y d minus 2 d square plus 9 at this function, and this will give you 0. So now you have from the non-homogeneous equation you come to the homogeneous equation. So if you will find out its auxiliary equation, so its auxiliary equation will be lambda minus 2 lambda square plus 1. This will correspond this particular part, and lambda square plus 2 lambda plus 4, and this will correspond with the homogeneous part. So this will be lambda plus 2 whole square and lambda square plus 9 lambda minus 2 equal to 0. So lambda can be 2 plus minus 3 iota minus 2 minus 2. So your solution will be auxiliary solution I am talking about. It will be C1 e to the power 2x plus C2 cos 3x plus C3 sin 3x, and this this is our, we are interested in this part to see the particular solution. And what will be the other one? E to the power minus 2x plus C5x e to the power minus 2x. So this will be our homogeneous solution, you can say. So look, ypx is equal to c1 e to the power 2x c2 cos 3x plus c3 sin 3x for the particular solution. So try this one. You have to calculate its first derivative, second derivative, then you have to put it into the given equation. Then we can follow up. Wait a second. I think here we have done some kind of error. If you will observe that for this we need this kind of d minus 2, and for this we need d square plus 9. These are the roots of 2 plus minus 3 iota. So what we have to consider it? We have to consider it uh, d square plus 9, or in fact I would say d minus 2 whole square plus 9, this one. So then we can have 2 plus minus 3 iota. So let me correct this one. So it will be d minus 2 whole square 9. So again this will be lambda minus 2 whole square, and this will be again lambda minus 2 whole square plus 9. Now we can have here this kind of, and here it will be C1, it will be C2, and it will be also C3, and it will be C4. So we are interested in this C1, find out this C1, C2 by putting into the given differential equation. So this will be C1, C2. So try this, calculate its first derivative, second derivative, and put into the differential equation, and then try to find out, determine this C1 and C2. So let me do the derivative here. So here we can also say this one as a general solution also. We can put this value of C1, so calculate the C1, C2 and put in the equation and then we'll get the general solution. So yp dash x will be e to the power 2 C1 cos 2x, sorry, 3x C2 sin 3x plus e to the power 2x minus 3 C1 sin 3x plus 3 C2 cos 3x. Next one is second derivative. So 4 e to the power 2x C1 cos 3x plus C2 sin 3x. One part is this, and if we will differentiate this one and here this one, then we can combine these two. So from here we will take 6 and here also 6. So it will be 12 e to the power 2x minus C1 sin 3x plus C2 cos 3x. And the last part will be e to the power 2x. Again, it will be minus 9 C1 cos 3x plus 9 C2 sin 3x. So this will be negative sign. Now we have to put all these values in the given differential equation, and our given differential equation is this y double dash plus 2y dash plus 4y equal to this one. So we will put into this. So y double dash will be stays as it is. So what we will do, we will take this one. So this will be as it is. Next, what we have to do, we have to put this yp dash, and this has been multiplied by plus 2. So this has been multiplied, yes, plus 2. So here it will be addition of 2 times of whole of this. So this will give you, next one is 4 times of our yp. So 4 times of this yp. So this will be 4 times of this yp. This will be equal to triple 1 times e to the power 2x cos 3x. So this is our whole inequality equality. We have to solve this equation for this C1 and C2. So solve it and tell me the value of this constant. Solve it and tell me the value of these constants. It seems a little complicated expression, but it is not like that. If you will solve it smartly, there is two factor. One factor is e to the power 2x cos 3x, and another factor is e to the power 2x sin 3x. So you can combine each coefficient and can equate the compare the quantities. So if I would take here e to the power 2x, and let me mark with some red one, cos 3x, cos 3x, these are. Okay, so here it is. First one is 4c1. Next 12c2. Okay. Next is 12c2. After that, this is minus 9c1, plus this one is 2 times is also outside, so it will be 4 times of c1. Here this will give you 3 times of c2, and this last one is 4 times of c1. This will be triple one, since it is a coefficient of e to the power 2x cos 3x. So what it will give you, if you observe, so this is 12, 12 plus this 3 is 15. So I think we missed something here. Okay, so here is 2 also, this whole bracket. So this will be not 3, this will be 6. So 12 plus 6, 18, C2. And what about C1? So C1 will be 4, 4. This 12, 12 minus 9 is 3. So 3 C1. So it will be C1 plus 6 times of C2. It will be 37. So this will be your equation number 3. Now for sin x kind of term, you have to see this. You have to remember that you have some multiplication outside, otherwise it will be difficult for us to get correct answer. So this coefficient must be goes to 0 because in RHS there is no such term. So first one is 4 times C2. From the next one is minus 12 times C1. Then the next from the next term is 9 times of C2, and the next one is 2 and 2 multiplying 4 times it would be, so 4 times of C2. From the next one is minus 3 times of C1, or in fact 6 times since 2 is outside. Next one is 4 times of again C2. This must goes to 0. So from here you will get minus 12 C1 minus 6 C1, it will be minus 18 C1. And from here 4, 4, 4, 12, 12 minus 9, it will be 3 times of C2. Then C2 will be 6 times of C1. And if you will put this value in equation number 3, then you will get 37 times of C1 is equal to 37. Then C1 will be 1 and C2 will be 6. Earlier it was looking so complicated expression. Now the output is simply 1 and 6. So what will be your general solution? We need to put into this general solution, that is in this star. So C3 e to the power minus 2x plus C4 x e to the power minus 2x. I think it is like that only. C3 e to the power 2 minus 2x and C4 e to the power x minus 2x. Next factor will be e to the power 2x, C1, and we have to put the value of C1 and C2. So next one is plus e to the power 2x, C1 is 1, so it will be cos 3x, C2 is 6, it will be sin 3x. So this will be your general solution of the given differential equation, is the general solution of the given differential equation. I hope it is clear till now. Okay, so next one is question number 5. Solve x square y double dash plus 5x y dash plus 7y equal to 0. So clearly this is a special kind of equation, that is Euler-Cauchy equation. So you need to make the substitution of the independent variable x equal to e to the power z, or z, you can say z equal to ln x, and you have to convert this equation, that is with respect to dy by dx, that is y is a dependent variable and x is an independent variable. Then we convert this differential equation, transform into the z as independent variable and y is depending on z. Then we have to solve it, then we have to again put the value of z. So try this one, after that we will discuss. So let us substitute our independent variable. So put x equal to e to the power z, or you can say z as ln x. So from here you will get dz by dx as 1 by x. So you want to substitute this dy by dx with the dy by dz. So by chain rule, you will get this one, and dz by dx is nothing but 1 by x. So from here, you will get that x dy by dx is equal to, let me write it another form. So x dy by dx is will be equal to dy by dz. Okay. So while the second derivative, this will be d by dx of dy by dx. We will play a little smartly. So we know that this dy by dx is, we will do like this and put the value of this dy by dx, and dy by dx is 1 by x dy by and dz. So it will give you minus 1 by x square dy by dz, and the other factor will be d square by dz square. I am applying chain rule, dz by dx. So it will be d2y by dz square minus dy by dz. This will be x square d2. This will be like this. So you know the value of x square d square y by dx square, and you know the x dy by dx. We have to put in the initial differential equation given. So it will be d2y divided by dz square minus dy by dz. This is our first term, plus 5 times dy by dz plus 7 times y equal to 0. So if you will solve it, you will get minus 4 dy by dz plus 7 by equal to 0. So this is your differential equation with respect to the independent variable z. So again, with the help of earlier methods, you can form auxiliary equation like this, and lambda will be 4 plus minus 16 minus 28 divided by 2. So this will give you 2 plus minus, this will be 12. So under root 3 iota. So your y1, your general solution with respect to z will be e to the power 2z c1 cos under root 3z plus c2 sin under root 3z. So this is your general solution with respect to z. Now we have since we have substituted e to the power z as x, or you can say sorry, here okay, correct. So e to the, we have substituted e to the power. It will be, there is a sign. This will be plus 4. Okay, with plus 4, and this will be your minus 4 minus 2. It will be minus. So we will put this z as ln x. So you will get this as 1 by x square and c1 cos under root 3 ln x. So while solving the Cauchy-Euler equation, we cannot assume x equal to 0. X should be not equal to 0, and so we have to work either x positive or x negative. So here we are working with x positive. So we don't need to apply here mod. So we just write ln x c2 sin under root 3 ln x divided by x square. So this will be your general solution of the given differential equation. Okay, so we have solved one question that is based on Cauchy-Euler equation, that is homogeneous Cauchy-Euler equation. If I would say, what if we have given some non-homogeneous Cauchy-Euler equation? So for that is the next question, number 6. Find the general solution of y double dash minus xy dash plus 2y x ln x. So you know that we have to convert this into the constant coefficient differential equation. If you will observe from this question number 5, earlier it was a variable coefficient differential equation. Then we have converted into the constant coefficient differential equation. So same way we have to convert this into with respect to the variable z, independent variable z. Then we will apply the method, auxiliary equation method, and then method of you will get to know, since it will convert into the constant coefficient, so you can apply method of undetermined coefficients. So try this one. First, convert this into the constant coefficient non-homogeneous second order differential equation. Then you will apply that method of undetermined coefficient. So let me start with the one. So again, we will put, or you can say substitute z equal to ln x. So I am skipping some step. If you will observe that this is nothing but d minus d into d minus 1 of z, where d is d by dz, and it is d and it is by. So in the same manner, it will be d into d minus 1 minus d plus 2, applying at y. This will become ln x is z and x is e to the power z. So you will, where this d is d by dz. So that means this will be, if you will solve a little, d square minus 2d plus 2 y z. Now we have this equation. So non-homogeneous equation. So we need to follow that method of undetermined coefficient. So what we can do, we find out first of all what, where, when this z e to the power, excuse me, this z e to the power z annihilate. So we know that e to the power z annihilate when this will be b minus 1 e to the power z. But since it is z times it, we know that when z comes to the linear independent solution, when it will be some like this square, repeating of roots. So therefore, what we will do, we will apply both sides this d minus 1 square, 2d y, d minus 1 square, z e to the power z, this will be 0. Now you get to the constant homogeneous kind of differential equation of order 4, oh sorry, of fourth, yeah, order 4. So from here you will get the auxiliary equation like this: lambda 1, lambda minus 1 square, lambda square minus 2 lambda plus 2 equal to 0. So one root is 1 1, and this another one root will be 2 plus minus 2, 4 minus 4 to the 8 divided by 2. So if you will solve it a little, you will get 1 1 1 plus minus I think iota So let me just cross verify whether it will be the case or something else. Yeah, 1 plus minus alpha. That is correct. So now, what will be your general solution? I will like this homogeneous part first. So it will be e to the power x c1 cos x plus c2 sin x. So this is wrong. Why? Our independent variable was z. So we cannot write x here. So we should replace at x at each place with z. So this will be z, z, z sin z. Next one is c3 e to the power z, c4 z. So this is our homogeneous part, and this is kind of particular part. So we are interested, look for yp z as c3 e to the power z plus c4 z e to the power z. So what you want to do? You want to compute its derivative. So it will be c3 e to the power z, c4 e to the power z plus c4 z e to the power z, and yp double derivative will come out to be c3 plus 2 times of c4 e to the power z plus c4 z e to the power z. And our differential equation is have having this kind of form. So we need to substitute this yp in this equation. So this first double derivative will be stay as it is, c4 z e to the power z. Then minus 2 times of this first derivative. If I solve a little, so it will be c3 plus c4 e to the power z minus 2c4 z e to the power z plus 2 times of c3 e to the power z equal to what we have in equal z e to the power z. So from here we need to compare the coefficients. So if you will compare the coefficient z e to the power z, it will be 1 from RHS, and in RHS coefficient of e to the power z is 0. So for simplicity, what we will do, we first compare this e to the power z coefficients. One is this, one is this, and this one. So this is C3 plus 2C4 minus 2C3 minus 2C4 plus 2C3 equal to 1. So 2C4 will be cancel out, 2C3 will be cancel out, and this C3 will be 1. And what about the other? Sorry, so it will be, it is the coefficient of e to the power z, so it will be nothing but 0. So for C4, we become our calculation become a little easy. We can just replace C3 as 0. So if you will observe, there is no such C3 involved in z e to the power z. So it will be C4 minus 2C4 plus 2C4 is equal to 1. So C4 will be 1 from this. So what is the general solution will come out to be? General solution will come out to be our C3 is 0 and C4 is 1. So it will come out to be e to the power z, C1 cos z plus C2 sin z plus z e to the power z. So let me just verify it. Will it be such case? So our answer is question number 6. So this is correct. So now what we have to do? We have to replace this z with x. Then x is equal to e to the power z. So it will be x c1 cos ln x c2 sin ln x plus x ln x. So this will be your is the general solution of the given non-homogeneous Cauchy-Euler differential equation. So here again I am saying, since here n and x, so domain will be strictly positive. So that's why I am not written here ln mod x. So now you have also solved Cauchy-Euler equation with non-homogeneous part. So next question is question number 7. Solve the equation to find the general solution. And the equation is 1 plus y double dash 1 plus x y dash plus y cos ln 1 plus. So if you will observe it properly, this is nothing but a alternative form of Cauchy-Euler equation. Here ln x, or you can say this x square y double dash type of term, here role play 1 plus x whole square. So there is nothing but a dummy variable, you can say 1 plus x in the place of x. So try this one. It's similar to question number 6. Try. So as I told you, this is a kind of Cauchy-Euler equation. So let me convert into that form. Here we substitute. What we will substitute? Z is equal to ln 1 plus x. Again, if you will observe here, dz by dx will be 1 by 1 plus x. In the same manner, dy by dx will be dy by dz divided by into dz by dx by chain rule, and it will give you 1 by 1 plus x dy by dz. That means 1 plus x times this dy by dx will give you dy by dz. So second term will be dy by dz directly. Now for d2y by dx square, d by dx of this dy by this dx. So this will give you, from this first part, if you observe that, this will give you 1 by 1 plus x whole square dy by dz with negative sign, 1 by 1 plus x whole square. Here it will be double derivative, it will be single derivative. So this will give you 1 plus x whole square d2y by dx square will be d2y by dz square minus dy by dz. So it is clear. Now you can convert this variable Cauchy-Euler equation into the constant second order linear ODE. How? It will come out to be d2y by dz square minus dy by dz plus dy by dz plus y is equal to 4 cos z. So this will come out to be d2y dz square plus y 4 cos z. Clearly, this is a second order linear non-homogeneous ODE with constant coefficient. So again, from the auxiliary equation of annulate, we can also follow the analytic method. So for corresponding to cos z, we need d square plus 1 kind of differential equation. So here, if you will write it, it will be d square plus 1 y 4 times of cos z. Here d is nothing but d by dz. So for cos z, we again need to operate d square plus 1 y d square plus 1 over this 4 cos z. This will give you 0. Then again, it's a repetition of root, repetition of plus minus iota. So our general solution will be C1 cos, again, since independent variable is z, so it will be C1 cos z plus C2 sin z plus C3 z cos z, C4 z sin z. So this will be your general solution. So now the question arises, which will be the particular solution? So observe from this homogeneous part d square plus 1. So it is not repeating. So d square plus 1 is our homogeneous part. So this will be our homogeneous part. And this will play the role of particular part, and we have to find out this C3 and C4 by differentiating it 2 times. So look, yp z C3 z cos z plus C4 z sin z. So first derivative will be, what is first derivative? It's C3 cos z C4 sin z minus C3z sin z plus C4z cos z. Yp double derivative will be minus C3 sin z plus this C4 cos z. So if we will differentiate with respect to z, so this will give you C3, it will be repeating, so it will be 2 times. And if we will differentiate with respect to this sin z, C3z cos z plus C4z, in fact minus C4z sin z. And our differential equation is this. So we need to substitute this double derivative and this y in this, and we have to compare this coefficient. So what we will get? Minus 2c3 sin z plus 2c4 cos z minus C3Z cos Z minus C4Z sin Z plus C3Z cos Z plus C4Z sin Z, and this will be equal to 4 cos Z. So if we compare, this will cancel out. Anything more is cancelling out. This will cancel out. So we will left with this minus 2C3. This will be equal to 0 because there is no term of sin Z, and 2C4 will be 4. So this will give you C3 as 0 and C4 as 2. Let me confirm this. So it is correct. So your general solution with respect to Z will be C1 cos Z, C2 sin Z. Since C3 is 0, so we will skip that term, and C4 is 2 times of Z sin Z. This is our C4, fourth term. Now we need to convert into our original form. So what was that? C1 cos ln 1 plus x, C2 sin ln 1 plus x plus 2 times of ln 1 plus x. Oh, let me little rearrange it. So this will be sin ln 1 plus x is the general solution of the given differential equation. Okay, so we have seen one more Cauchy-Euler type differential non-homogeneous type equation, and we have find out its solution. Now, till now we have deal with non-homogeneous equation with constant coefficient. In the next some questions, we will deal with non-homogeneous variable kind of coefficient. And as I told you in the starting of the class, we will be able to solve those equations only by variation of parameter. In that scenario, this method of undetermined coefficient will not work. Let me write that question. Find the general solution of second order ODE y double dash plus y is equal to 1 by 1 plus sin x by method of variation of parameters. We need to apply the method of variation of parameters. For that, we need to find out first its homogeneous solution, that is y1x and y2x. Then we have to apply this method of variation of parameters. Try this one, then we will discuss it. So let us start discussing this one. So what is its homogeneous part? So it will be y double dash y equal to 0, and its corresponding auxiliary equation will be lambda square plus 1 equal to 0. So the root of this auxiliary equation will be this one, and homogeneous solution is C1 cos x plus C2 sin x. Now we need to discuss its particular solution with the help of this method of variation of parameters. So method of variation of parameters tells us that ypx you consider as c1x, y1x. So here it is your y1, it is your y2 plus c2x and y2x. So it means you have to calculate this c1x and c2x. Since we are calling variation of parameters, so we have taken this c1x as a parameter and we are varying it. And we are seeing what will be the value of c1x and c2x. And the reason is here in this RHS, there are two limitations of method of undetermined coefficient. As I told you, if the RHS has not some kind of simple function, so it is not a simple function, so you cannot go with that annihilating approach. So you need to follow this one approach. So what is C1x? Where this C1x is minus y2 x into fx. Fx means the function that is present at the RHS. Divide by Wronskian of y1 y2 x. Its integration with some this arbitrary constant which is coming because of this integration. This is an definite integral. Although we are going to ignore this d1, or you can say we are going to take this d1 to be 0, since we are interested in the particular solutions. And c2 will be y1x fx divided by Wronskian of this y1 y2 at x d plus some arbitrary constant. So it's obvious we need to first calculate this y1 y2. It's Wronskian. So solution is y1 is cos x and y2 is sin x. So it will be minus sin x and it will be cos x. So it will be nothing but 1. So this task a little become easy for this with respect to this Wronskian. Then C1 will be, since y2 is sin x and this function is 1 plus sin x and Wronskian is 1. So this will be your integration plus some constant d1. So what you will do, we will apply this constant after doing the integration. So what you will do, you will multiply with the 1 minus sin x in the numerator as well as in the denominator. So this will make a little easy task for you. This will give you as cos square x, and sin x divided by cos x is nothing but 10x. So it will be secant x 10x minus, and this will be 10 square x. Since we don't know the integration of 10x directly, what we will do, we will convert into a secant square x. So first term will be sec x minus, this second term will correspond to secant square x minus 1, that is 10x minus x plus some constant d1. And what we will do for our simplicity, we will take this d1 to be 0. Similarly, c2x will be by1x, that is cos x, and that fx is 1 by 1 plus sin x, and Wronskian was 1. So cos x is the differentiation of this denominator, so it will be nothing but ln mod of 1 plus sin x. Okay, now with some d2, again we will take d2 to be 0 since we need the particular solution. So what will be your particular solution? it will be c1x times y1x. So what is y1x? Cos x. So you will multiply cos x with this whole equation. So it will give you sin x minus x cos x minus 1 plus this c2x into sin x. So it will be ln mod 1 plus sin x into sin x. Now you got your particular solution too. So what is your general solution? It will be c1 cos x, c2 sin x plus sin x minus x cos x minus 1 plus sin x into ln 1 plus sin x. So this will be your whole general solution. But since it is one time of sin x and it is all combination of c2 sin x, so what you can do, you can combine this with this one. So your general solution will be simplified in the form of x cos x. You cannot combine since it is containing x plus sin x ln mod of 1 plus sin x. This is your general solution. General solution of the given differential equation. Okay, let me give you one more question on this method of variation of parameter. Find the general solution of second order ODE y double dash minus 2y dash plus 2y is equal to by the method of variation of parameters. So clearly we have given second order differential equation with constant coefficient, but here in RHS we have a not a simple function. So again we have to take the help of method of variation of parameters. So the approach is similar to this question number 8. Try this one first yourself, then we will discuss. So let us start. What is its auxiliary equation because of this homogeneous part? It will be like this. Uh, this is 2 plus minus 4 minus, this will give you 1 plus minus iota. Is it correct? So let me make it a little easy for us. Let me take this one as y, 1. So if this will be 1, then this will not be the case. Then we get directly repeated roots. That will be 1 and 1. So our homogeneous part solution will be C1 e to the power x plus C2 x e to the power x. This will be our homogeneous solution. Now we need to discuss this particular solution. Y1x is this, y2x is this. What will be its Wronskian? Y1, y2x. Wronskian will be e to the power x, its differentiation, x e to the power x, and its differentiation is this. So this will give you e to the power 2x. Okay. So now particular solution is ypx is of the form c1x y1x plus c2x y2x, and c1x will be minus y2x fx divided by Wronskian y1 y2 x dx plus some constant d1. Since we are again going to take it 0, so I am removing it. And c2x will be y1x fx divided by the Wronskian of this y1 y2 at any. So this is c1 c2 that we have to calculate. Our y2 is x e to the power x, okay, and our fx is x e to the power x ln x, and divide by x e to the power 2x. It's Wronskian. So this will give you minus x square ln x dx. Now by that Eilert rule, our will be our first choice for the integration, sorry, for the differentiation, and x square will be the second choice for the integration. So this will come out to be x cube ln x divided by 3, negative sign. Ln x will give you 1 by x, and this will be x cube divided by 9. So it's a simple integration. You can do it by yourself. So this will be x cube by 9 minus x cube ln x divided by 3. This is your C1. Now C2x will be y1x, that is e to the power x, and RHS is x e to the power x ln x divided by into the power 2x dx. So this will give you x ln x dx. So its integration is x square ln x by 2 minus x square by 4. So you got x c1x and c2x. What is a particular solution then? C1x will be multiplied our first solution e to the power x. So x cube by 3 minus x cube ln x divided by, here it will be 9, into e to the power x plus. So next one solution is x e to the power x y2x is. So again we can multiply x cube ln x divided by 2 minus x cube divided by 4 e to the power x. So if you will solve a little with respect to this, so you will get x cube by 9 minus x cube by 4. So it will give you 1 by 9 minus 1 by 4. So it will give you minus 5 by 36. You can say while this other part, let me just write it, minus 5 by 36 x cube, and this minus 1 by 3 and plus 1 by 2. This will give you 1 by 6. So we can write for simplicity 1 by 6 with respect to this x cube ln x cube ln x minus 5 by 36 x cube e to the power x. This will be your particular solution. So what will be your general solution? C1 e to the power x plus C2 x e to the power x plus this factor, or you can smartly write this 6 ln x minus 5 divided by x cube e to the power x divided by 36. So this is your is the general solution of the given differential equation. Okay. Now the last question of this class is as follows. Till now we have considered in the 8th and 9th question for method of variation of parameter. We have considered constant coefficient in LHS, but not a simple function on RHS side. But now we will consider variable coefficient in LHS as well. So find the general solution of the second order ODE x y double dash minus 2x plus 1y dash plus x plus 1 y is equal to x squared by the method of variation of parameters. Try this one. And this will be the last question of today's tutorial session. In the earlier two questions, we have given a standard form of the form like y double dash plus it is its coefficient is 1. Another form has some px or qx that are constant. But here we have given the here x times this one. So what we should first do? Okay, so here is one more change I would suggest. The change is, since it's a variable kind of equation, so here we should know at least one solution by knowing that e to the power x is one of the solution of its homogeneous part. So in the last tutorial, we have learned if we know one solution, then with the help of Wronskian, we can find out the another solution by the Abel's formula, you can say. So for that, we need to convert this given differential equation into some standard kind of form, like we will divide the whole equation with x. So this will give you 1 plus 1 by x y x. So it's obvious x cannot be 0. So you can take positive domain or a negative domain. So for safer side, I'm taking positive domain. So from here, you know that your px is minus 2 plus 1 by x, and your qx is 1 plus 1 by x, and your fx is x. If you know the first solution, to find out the second solution, we know from the Abel's formula that it would be nothing but y1x integration 1 by y1 x whole square e to the power minus p1x dx dx. Let me just confirm the formula so that we shall not arrive any kind of calculative error. So yes, it is correct. So now we can proceed. So y1x is e to the power x, since we know one solution, and this is 1 by e to the power 2x e to the power minus, and minus sign is there with p, so it will be 2 plus 1 by x dx. So this will give you e to the power x 1 by e to the power 2x. This will give you e to the power 2x into, oh sorry, plus ln x dx. So this will give you e to the power x integration x dx. So this is x square e to the power x by 2. So you got to know the another Li solution of this homogeneous part for the differential equation is x square e to the power x by 2. Now you need to apply the method of variation of parameter. For that, you should first calculate this Wronskian. So let me, for simplicity, let me write that homogeneous solution first. So homogeneous solution is C1 e to the power x plus, since it's a constant, so I will include this into the C2 x square e to the power x. So we have this y1x and y2x. Now calculate its Wronskian e to the power x, and its differentiation is again e to the power x square e to the power x. So it will be 2x e to the power x plus x square e to the power x, which will give you 2x e to the power 2x. This is your Wronskian. So what is your particular solution? The particular solution is C1x y1x plus C2x y2x, and C1x is minus y2x fx divided by Wronskian y1 y2 x dx. And since constant is again going to take 0, so I'm not writing it. So let me write this y2x. Y2x is x square e to the power x. And what is your fx? Fx is x here from this changed one. And your Wronskian is 2x e to the power 2x. So from here, 1x will cancel out and you will left with minus x square e to the power minus x with half. So this will give you minus half x square e to the power minus x divided by minus 1 with negative sign. 2 to the power x minus 1 whole square plus 2 e to the power minus x divided by minus 1 whole cube. So this will be your, so this will give you x square minus 2x plus 2 divided by 2 e to the power minus x. This will be your C1x. Now C2x will be integration y1x fx divided by Wronskian of y1 y2 at any x. So y1 is here, y1 was e to the power x. This is x divided by um, 2x e to the power 2x. I think it was this here. So this will give you x will cancel out 1 by 2 e to the power minus x dx. So this will give you minus e to the power minus x divided by 2. So what will be your particular solution? Particular solution is c1x times y1x, that is this x square minus 2x plus 2 divided by 2 e to the power x, or e to the power x minus x will be cancelled out. For the second part, you will multiply x square e to the power x with this factor. So this will give you minus x square by 2. So this will give you x square by 2 cancel out. This will give you minus x plus 1. So I think there must be some calculating. Okay, minus minus will be plus now. So this will be plus. So since this is plus, so this is plus. So this will be x plus 1. So what is your general solution in this scenario? C1 e to the power x, C2 x square e to the power x plus x plus 1. This will be your is the general solution of the given differential equation. So that's all for today. So till now we have solved some questions that are, first of all, that are higher order and constant coefficients homogeneous differential equation, then Euler-Cauchy type of differential equation, homogeneous as well as non-homogeneous, and then we find out general solutions with constant coefficient and non-homogeneous part with the help of you can say this a method of undetermined coefficient. Then we will consider some non-simple kind of function for the non-homogeneous part, and also deal with this variable coefficient kind of second order differential equation with the help of method of variation of parameters. So if you have any query, then you please ask. Otherwise, let's end today's session and meet on next Tuesday 6 to 8 for week 4 like tutorial lecture. Okay, thank you. Yeah. I think if there is no doubt, so let's end today's session. Thank you.